In example 5, we're given two different vectors, vector v and vector w, and then we're going to find the new vector, vector u, algebraically. And we won't worry about graphically right now, although that can be done, but it takes the use of a protractor, and you have to be pretty precise. The algebra is a little bit more precise than that. So for part A, we have vector u, and it's a scalar multiple of 3, and we want to multiply vector v. It's going to be important for you to keep track of your letters. Those letters are going to indicate which vector to use. So vector v is -2, 5. For scalar multiplication, we're just going to multiply the scalar multiple by each component on the inside, whether you have 2, 3, or even more components. So 3 times -2 is -6. And then 3 times 5 is 15. And that should be just a sideways v right there. So we'll just make it a little bit. Oop, that was a little worse. Try to make it a little bit better here with the stylus. There we go. And we'll move on to the next one down here at the bottom, vector b, which is part b, vector u is going to be v plus w now. So if we had to write this all out, we would write it as -2, 5, that's vector v, plus 3, 4, that's vector w. To add vectors, we're just going to add the x and y components together, or if there are more, you just add those together as well. So -2 and 3 is 1. We're looking right now at the first x, second x right here, just add those together. And then now 5 plus 4 is 9. Guess we should probably circle these, box them in. And we'll now continue with part C here. So that's vector w minus vector v. So remember here that vector w was 3, 4. And we'll scroll back up. So we've got 3, 4. And we want to subtract now vector v, which was -2, 5. To perform this operation, we're just going to subtract the x components. So 3 minus -2 is the same as 3 plus 2, which happens to be 5. Now we'll look at 4 minus 5. So 4 minus 5 is -1. Moving on to part D, vector u is going to be -5, which is a scalar multiple, times vector v. So vector v was -2, 5. So we'll just multiply the -5, the scalar multiple, times both the x and the y component. -5 times -2 is 10, and -5 times 5 is -25. A little reminder there of the top, or at the top of each one of those vectors. We're now going to do vector u being w minus 2v. So here's how we would write that out. 3, 4 is vector w minus 2. And then we've got -2, 5 for vector v. We want to do the multiplication part first, same thing as order of operations would be, and then we'll do the addition or subtraction. Now you have a choice here whether to distribute the -2 and make this an addition problem, or just distribute the 2 and keep it a subtraction problem. It's probably going to be best for you to distribute the entire -2 across each one of these on the inside. It's not really the distributive property, but it kind of works like that. If we distribute the entire -2, this will be a vector addition problem. So -2 times -2 is 4, and then -2 times 5 is -10. Then we'll just add the x components together. So 3 and 4 is 7. And then we'll add the y components together. 4 plus -10 is -6. And then finally in part F, we have a few scalar multiples, and I'll write this out for you. 4 times vector v is -2, 5. Just remember to keep track of your letters. And then we've got 3, another scalar multiple, times vector w, which is 3, 4. So we want to do the multiplication part first for each one of these, and we can do it at the same time. So 4 times the x and the y component of vector v, 4 times -2 is -8. And then 4 times 5 is 20. Then we'll distribute the 3, or multiply the vector 3, 4 by 3, I should say, I suppose. And so 3 times 3 is 9, and then 3 times 4 is 12. And finally, we'll do the addition. So negative 8 plus 9 is 1. We're looking at the x component now of the first one and the x component of the next one. Now we'll look at the y components, which is 20 and 12, and just add those up. So you get 32.